All right, in the previous video, I showed you how you could complete this expression, the square of this expression. And by the way, we got, I think it was 2x plus 1, I'm reading off what we got last time, minus 5, and that was the expression. In other words, this thing here, that expression there, and this expression, oh, we've gone out of focus, please go back and focus, there you go. And these two were in fact the same. And if you wanted now to complete the square, you could just make this equal to 0. So in other words, you complete the square first, make the answer equal to 0, and then strip everything away. So let's see how that plays out. So we could just do that quickly. So now I'm going to add 5 to both sides. There it is. So now I've got 2x plus 1 all squared is equal to 5. I'm going to divide both sides by 2. There it is. I've got an x plus 1 all squared is equal to 5 over 2. I'm going to find the square root of both sides. Square root of a square leaves me with an x plus 1 is equal to plus or minus root 5, 5 on 2, and it's the square root of the whole thing. And I'm going to subtract 1 from there and subtract 1 from there, leave me with an x is equal to negative 1 plus or minus 5 on 2. And there is my answer. Now, there's plenty of ways you can get to there without doing it that way. So what I'm going to do now is just show you probably a preferable way of doing it. So in this case, if it just said complete the square, you could just go ahead and do what we just did last time. But in this case here, we end up with a messy situation if we put an external bracket, and within that external bracket we've got components that we're moving to the other side which also belong inside that bracket, and that's difficult to do. So let's have a look at a preferable way of achieving that, and we're going to see if we end up in the same place, see if we end up with the same answer. All right, let's take a look at that now. I'm actually going to I'm going to actually do it on a separate sheet of paper, so I'll actually have another sheet of paper here. So when you look for answers and stuff, you'll need to look for 2 separate sheets of paper. So this is Theta exercise 17.06, question 8. I put version 3 here. All right, here we go. So version 2 and 3. So here's our expression. It's 2x squared plus 4x minus 3 is equal to 0. That's what we're after. Okay, so a good way of doing this, rather than putting the 2 outside the bracket and then factorizing, is simply divide everything by the coefficient of the x squared. So let's just go ahead and do that. So I'm going to make this divide by 2, this divide by 2, this divide by 2, and of course that divide by 2 as well. So 2 divided by 2 just leaves me with an x squared. 4 divided by 2 is a 2. That becomes a 2x, and we can leave that as a minus 3 on 2 is 0. Now, let's get the 3 on 2 on the other side. So I'm going to add 3 on 2, add 3 on 2. So now we're left with an x squared plus 2x is equal to 3 over 2. Let's take the coefficient here. So we add it, and halve it, and square it. We're going to add it, and halve it, and square it to both sides. Sorry about the crossed outline going through this bit here. All right, so we know that this bit here is the perfect square. There it is, 2x squared, and we've got a plus, and the contents of that is a 1. Oh, well, sorry, that's not a squared inside. It is a square outside. Easy mistake to make. Don't get caught out like I did then. Not good. All right, so we've got a 3 on 2 plus a 1 squared is 1. So we've got a 1 plus 3 over 2. And if you're not sure how to do that, an easy way is just to go 3 over 2. And we know that 1 is 2 over 2. And 2 over 2 and 3 over 2 is 5 over 2. So I've got 5 over 2. And we've got an x plus 1 all squared is 5 over 2. So let's now play around with this a bit. So in fact, I haven't left enough room really to write even the plus or minus in there. So that was silly. Again, planning how you set this out means it's going to be easier to write in the components you need to. I'm going to find the square root of this side and the square root of this side. Square root of a square, and this is plus or minus. So I've got x plus 1 is equal to plus or minus 5 on 2. It's root 5 on 2, or the square root of all of 5 on 2. And I'm going to subtract 1 from both sides. There it is. And I've got x is equal to -1 plus or minus root 5 on 2. There it is. So there is my answer. And I'm just looking at the other answer we got just before. And yes, we get exactly the same. Now, of course, they don't want that. They want something a bit different, and that's the decimal form. So let's find out what that is equal. So x is equal to either one of two things. Let's have a look what that is. So I've got minus, I'll just write that in. So I've got minus now, -1, plus, we'll do plus first, and we're going to have the square root of 5 on 2. There it is. And I get 0.58. 0.58. I'm just writing this in. You can't see that very well, sorry. The next one, though, is the same thing, but minus. So I've got -1 minus root 5 on 2. There it is. And we get -2.58. Or -2.58. Now, really, we should put the smallest one first. So I'm going to put x is an element of the set of -2.58, comma, 0.58. So expressing that in set builder notation, that's how I would put that. Or you could just say these two things, but do get these in order. Swap those two values around there. The examiners will like it better. Hopefully that makes sense, folks.